Select the major product that forms from the following series of reactions. So we want to look at what our starting material is, and it's a good thing to identify both the functional group and the number of carbon atoms. So we can see that we have an alkyne, because we have this carbon-carbon triple bond. We have simply 1, 2, 3, 4, 5, 6 carbon atoms. So we have here 1 hexyne. And we could also identify this as a terminal alkyne. So that just means an alkyne that is at the end of the chain. And so what we're treating this with in our first step is hydrogen gas and Lindlar's catalyst. So the first thing you might think of when you see this Lindlar's catalyst is, that's going to make a cis-alkene. And it will if you are using an internal alkyne. So sometimes students get a little confused, well, how are we going to get a cis-alkene out of this terminal alkyne? And you're not. So if you reduce a terminal alkyne, and you do so selectively, like we're trying to do here, this is a poison catalyst that will take an alkyne and just reduce it to an alkene. So if your alkene ends up being at the end of the chain, it simply will be a terminal alkene, so it will not have stereochemistry. So I'm gonna say 1, 2, 3, 4, 5, 6. So this, in this case, don't let it throw you off that this is not a cis-alkene, right? If there had been another group here, it would be a cis-alkene, because these two hydrogens are definitely gonna add to the same side. It's just when your alkyne itself is terminal that we don't see stereochemistry, because this alkene is not stereoisomeric. So we're going to get the 1 hexene, okay? And so this alkene, we'll make a note of it, is not stereoisomeric. That means it does not have a stereoisomer. All right, so all we're using this Lindlar's catalyst for here is to stop the reduction at the alkene. So we've got an alkene now, and now we want to ask ourselves, what are we doing in this next step? So we're treating this first with BH3THF, so that is going to be a hydroboration reaction, so hydroboration. And then the second step here has hydrogen peroxide and aqueous sodium hydroxide. So this is the oxidation conditions. So hopefully we remember that when we do the hydroboration oxidation of an alkene, that we form the anti-Markovnikov alcohol, which is to say that we form the alcohol where the hydrogen has added to the least substituted carbon and the hydrogen has added to the more substituted carbon. So we're going to end up with a primary alcohol. And we just want to make sure that we have the right number of carbon atoms. So let's go ahead and count and make sure we still have 6. And the reason why we know that this is the primary alcohol is because we have to recognize that hydroboration oxidation is our way to do the anti-Markovnikov addition of water overall. Okay, we're adding a lot of stuff besides water, but overall we've added a hydrogen and an OH. So we just want to pick that answer out of here, and it looks like D. Let's just count and make sure that we have the right number of carbon atoms, and we do.